Have you seen a balance like this before? When each side of the balance has an equal mass, the balance is, well, balanced. In math, equations are kind of like balances, because the equal sign in an equation tells us that the values on each side are equal to one another. This is true not only with numbers, but with equations involving variables too. So when we have an equation like x plus 10 equals 16, we know that the left side, x plus 10, must have the same value as the right side, 16. We can use this fact to help us figure out the value of the variable x. So how do we do that? Well, there are a few important steps we follow to solve an equation like this one. First, we need to isolate the variable by using the inverse operation. Isolating the variable means getting it by itself on one side of the equation. Right now, the variable is on the left side of the equation and it's not isolated because 10 is being added to it. To isolate the variable, we need to use the inverse operation. Inverse operations are opposite operations, which means they undo each other. For instance, the inverse of addition is subtraction. If we start with a number like 0, add 10, and then subtract 10, we would still just have 0. So subtracting 10 cancels out or undoes adding 10. Let's apply that to our equation x plus 10 equals 16. Don't forget, we want to isolate the variable by using the inverse operation. Since 10 is being added to x, we need to use the inverse operation, subtraction, and subtract 10 from x. Adding 10 and subtracting 10 cancel each other out, giving us x plus 0 on the left side of the equation, which we can write as just x since adding 0 to anything doesn't change its value. Do you remember how earlier in the video we learned that an equation is like a balance, so both sides must be equal? To keep the equation balanced, we need to do the same operation on both sides of the equation. So if we subtract 10 from the left side of the equation, we also need to subtract 10 from the right side. 16 minus 10 equals 6, so now we have x on the left side of the equation and 6 on the right side of the equation. This means x equals 6. Of course, it's always a great idea to substitute the value we get for the variable into the original equation to see if our solution makes sense. If we substitute 6 for x, we have 6 plus 10 equals 16. Since the sum of 6 and 10 is 16, that means both sides have a value of 16 when x is 6, so x equals 6 is the solution to this equation. Let's try solving some more one-step equations together, starting with 42 equals z minus 25. Now, you might be noticing that this time the variable is on the right side of the equation. But don't worry, we can use the same steps. First, we need to isolate the variable by using the inverse operation. In this equation, 25 is being subtracted from z. The inverse of subtraction is addition, so to isolate z, we need to add 25 to z. Since subtracting 25 and adding 25 cancel each other out, this leaves us with just z on the right side of the equation. Then, to keep both sides of the equation equal, we also need to add 25 to 42. 42 plus 25 is 67, so 67 equals z. Before we move on to the next problem, let's make sure our solution is correct by plugging in 67 for z in the original equation. Since the difference of 67 and 25 is 42, that means both sides have a value of 42 when z is 67. So 67 equals z is the solution to this equation. Let's solve this equation next.